In the past couple of segments, we have looked at giving you a mental model of how to think about smart contracts from a programmer's point of view as objects with storage and code on a blockchain. And we've seen a couple of examples to get you used to the syntax of Solidity, the smart contract language we're using as a running example. And we've looked at the Dutch auction as a sample application that you could implement as a smart contract. Now, before we get into more details in the upcoming segments on how gas works and thinking about contracts, smart contracts versus legal contracts, for now the point of this segment is going to be to encourage you to try out writing smart contracts on your own. So it's going to be a walkthrough or demonstration of a hello world approach to writing smart contracts, just to get you off the ground with your first one. So I am going to be starting from scratch here. All I've got pulled up is my Remix code editor. And I have an empty file here except for the pragma at the top telling you which Solidity version to use. So to build this contract, I'm going to create a new contract object. That's the first thing. I'm going to give it a name. The idea behind the contract I'm going to build here is going to be something where there's one method to ring the bell, and it's just going to be a counter that keeps track of how many times you've invoked the ring the bell method. So my contract name will be bell tower, and you should remember from the mental model smart contract concepts segment that you should think of a smart contract as just some data and some code describing how to operate on that data. So I'm going to want to have a counter. A uint's appropriate for that, an unsigned int. So I will call this uint bell rung. Will be a counter of how many times has been rung. Now I intend for this to have just one function, ring the bell. This would be public. Anyone's going to be able to ring this bell. And the basic function of it is just going to be to increment the bell counter. It's really just about that simple. There's no visibility, or the visibility modifier here is public. There's no mutability modifier, so it's allowed to change the instance value. This is automatically going to be initialized to 0 by default, so I can leave it how it is. I could write it like that too, but that wouldn't be changing anything. Put comment here, not too important. One more thing that I want to add to this. I'm going to want to add an event so that I can see every time I ring the bell, I can see who rang it as something that shows up in the event log. All right, so I will declare a new event, call it bell rung. Now I can put a number here. Ring for the nth time. So the event will say what's the current counter, and I will also include who rang it. These are going to be the fields that I have for the event. So then in addition to ringing the bell, incrementing that counter, it's also going to emit this event. So I'll have it emit bell rung. I'll have the new value of the counter, and I will have message.sender. So this will tell me the address of whoever called this ring the bell function. So this should be enough. Now, I've been looking at the file browser view in Remix, but I can click on these other ones here to the compiler tab. Now I have auto compiler turned on in the compiler tab, so it's been compiling this program, all along. If I made mistakes, probably you saw this while I was typing. Like if I leave something off there, I'll get some kind of, warning from the compiler, and I can go follow what it does. Anyway, this is a very simple contract, so it's compiling now. Now, the next thing that I'm going to do is try this out by running it in the local JavaScript virtual machine. So I go to this tab, this deploy and run transactions, and my environment is going to be the JavaScript one. So it's just going to run a test instance of this contract in my browser. Okay, so I should be able to deploy this. It shows transactions recorded 1, so it simulated creating the contract with a transaction. It shows this little object here, bell tower, and an address. And I see this, I was expecting to see 2 methods. I forgot to make bell rung public, so I'm going to fix that. Now, autocompiler, it's already recompiled it. I do need to get rid of my old instances of that older contract, so now I'm going to deploy the new contract. Now when I look at it, okay, this is what I'd expect to see. I can see bell rung. This is my getter method. It gives me 0. Now ring the bell. It's a different color there. That is a potentially mutable transaction. You can see that this set transactions recorded. It may not be very clear that when I click this, it's simulating adding the transaction. I think that if I go to this little console view here and turn on listen and network, and maybe I just need to scroll down to the bottom here. Here, whenever I click ring the bell, it updates the transaction here. I don't want to go look in this transaction view. All I'll do is I'll click on this bell rung field again. You can see it now says 4 because I've rung the bell 4 times. All right, so every time I hit ring the bell and hit bell rung, you can see it updates that number. Now it's 6. Now I should be able to see the event log here as well. So if I do click the little down arrow to expand this simulated transaction, and I scroll down, it's showing me 2, that's the name of this locally simulated contract. Bell rung's the method that I call. So after you've run it locally and you're satisfied that it does, roughly what you want it to with local interaction, I like to next go to the testnet. So the way that I do this is by changing the environment from JavaScript VM to injected Web3. And that is going to link this to my MetaMask instance. You can see it loaded my address from MetaMask here, filled that in here. And so now when I do deploy, it's going to give me a MetaMask request to create this transaction on the Kovan test network. That's what I've set my MetaMask up pointing to. So when I hit confirm, I'm waiting for it to, it gives me a pop-up. You might not see the pop-up, but it does show that the contract deployment transaction has been committed. And it now shows the transaction recorded here. So here it's actually showing me a view of the contract on the test network. A better way of looking at the contract on the test network, though, is through a block explorer. So I can copy this address, and if I go to testnet, maybe kovan.etherscan.io, and I paste this address that I got from Remix, this is showing me the same transaction and the same contract creation that you can see through Remix. So here's the address of the contract. If I click on contract, you can see this bytecode. This is the compiled bytecode for the contract. Now I can interact with the testnet contract from here. So if I go and click ring the bell, it's going to give me a MetaMask pop-up. I have to approve this transaction. I'll go ahead and approve it. Now if I go and look at transactions involving this contract, I should see a new transaction show up in a moment, as soon as it gets confirmed. Okay, and there it goes. Here's the confirmed transaction that interacted with it. Now you can tell that it emitted a log event, but you're not being able to see exactly what information is in the log. So, you can see that it's the number 1 there. So what's happening is that we haven't told Etherscan about the high-level source code. So on the Ethereum blockchain, on the test network, all that's there right now is the Ethereum bytecode. In order to make the blockchain explorer give me a little bit more information, what I will do is go and copy my source code for this contract. When I look at the contract page on Etherscan, I'll see an option for verify and publish. Now I have to go to single file compiler version, it should be 8.4. I'm going to pick no license. And what this is going to do is it's going to be asking Etherscan to verify the source code by recompiling it themselves with that compiler. Oh no, I'm stuck by a CAPTCHA. Tractors. All right, that was a great CAPTCHA. Now, if all goes well, they're going to run the compiler on it. It's going to match exactly. They're looking for an exact match. Like they want to compile this Solidity code and get exactly the same bytecode as shows up on the Ethereum testnet. And it's going to say success. So that's good. When I now go back to the contract page, you'll see that there's a little bit more information about the contract there. It shows the source code there. It also shows all of the getter fields. So here I can see bell rung. It shows 1. That'll correspond exactly to when I click bell rung in Remix. It's showing me the same information there. I can go here and ring the bell again. That'll contact me via MetaMask, auto approve it. And now the same thing is going to happen here. If I wait for this transaction to be confirmed, I might have to wait a minute for it to be confirmed and to show up on Etherscan. Okay, there it goes. When I click read contract, it's seeing all of the updates. Now I can also use, so what's happening is that Etherscan is looking at the names of the variables and the names of the functions here. Really, it's looking at the ABI interface, which is just the function signatures and the descriptions of the variables. And what it's doing is showing me that information in this read contract info. It's showing me all the view transaction, or all the view methods. In this case, the getter for bell rung. It also shows me the mutable methods with write contract. So here I have to go connect it to my MetaMask. And now I can even use Etherscan as an alternative interface in order to call this method. So I go write. It's also going to give me another MetaMask prompt with the transaction to approve. I go ahead and prove it, and it'll let me view it, and it'll show me when this transaction is confirmed. There, it's already been confirmed. And sure enough, if I go back to read contract and reset it, there, it's 3, because now I've rung the bell a total of 3 times. I also get more information now when I go to the events tab in Etherscan. So here it shows me all 3 events. It shows me the name of the method I called. It shows me the name of the event, bell rung. The names of the parameters are there as well. And now I can also see these. I can interpret them as a number, as an address. I think it should be filling in this address and number for me automatically, but okay, Etherscan's not perfect. Anyway, you can see this is the address I'm using. I'm the one that's rung the bell that many times. So again, this is, I like to know that I'm seeing the same kind of information, whether I'm looking at a third-party block explorer like Etherscan, or whether I'm seeing the same thing through my development environment Remix here. Either way, you're getting the same view. If I ran a full node and connected it to the test network, I'd be able to go inspect this address the same way. You could go take this contract once you've created it and you want to show it to someone. You could go copy this address and send it to your friend. Anyone who's able to go access the MetaMask test network would be able to see, or who's able to access the Kovan test network would be able to see exactly the same information about your smart contract. Okay, so there you go. That is a quick walkthrough of how to use Solidity and the Remix development environment to write a contract and put it onto the Kovan public test network, and then go interact with that contract and observe it through Etherscan. Next time we are going to be talking about how to think about smart contracts as a comparison with legal contracts. And before that, we're going to talk about how gas is modeled in Ethereum, which is one of the sticky bits about Solidity programming that's a bit tricky, but it's an important concept to understand, especially in order to appreciate what is coming up for you in the DeFi segments later on in the course.